Good morning, my YouTube viewers. It is Crystal here, and I'm just here this morning to give you another code review. And I'm not allowed to make the notebook public, so I just have to give you the code review, and I can't give you a link to the Jupyter notebook because it's not public. Some people do that. Some people, when they have competitions, they don't want you to make your notebook public, which means other people can't look at it. So I'll give you the code review on this. It's a sentiment analysis community competition with Kaggle, and I scored 59% on this particular one. I tried really hard to improve my score. Like, I wanted to be able to remove the words that had less than 3 characters, but I was not able to do that on Tensorflow. You can do it in Python or Pandas, but you can't do it on Tensorflow. Just to show you, here's the question. So, and nobody's responded. I even, gave them the code. I asked the question and I gave them the code and nobody's responded. Just so you'll know that I did go on to Stack Overflow to actually ask for some help. And apparently on Stack Overflow, if I want to answer questions, I can answer questions, but I'm not sure exactly how to do it. But there we go. That's for another day. And my coding skills are not good enough to where I can go on Stack Overflow and answer questions anyway, even though I can if I wanted to. So this is the sentiment analysis community competition. I made 59% on it, which is not great, but it's better than the bottom. And here's your problem statement. For this competition, your goal is to decide how positive or negative a sentiment is. In this case, the sentiment is a phrase or a sentence. For each phrase is associated with one of the following labels: 0 for negative, 1 for somewhat negative, 2 for neutral, 3 for somewhat positive, 4 for positive. So that's your problem statement. And then what I did was I actually made the Jupyter notebook in Kaggle. So it's in my account for Kaggle, even though I can't make it public, so I can't give you the link for it in the description box. So the first thing after we have created our Jupyter notebook, we want to import the libraries that we're going to need. So we're going to import NumPy as NP. That's going to create NumPy arrays and perform numerical computations. We're going to import Pandas as PD. That's to create your data frames and process the data. We're going to import OS, which goes into the operating system. We're going to import ring, which is to do with string operations, and we're going to import string, which is also to do with string operations. We're going to import matplotlib.pyplot as PLT, which visualizes your data, and then we're going to import seedborn as SNS, which further visualizes your data statistically. Then what we're going to do is we're going to use OS to go in and get the files. And you can see we have 3 files, 3 CSV files, which what I did was I used Pandas to read the 3 files in and convert them into data frames. So I call them train, test, and submission. So you can see train is you've got your phrase and then you've got your sentiment. So you've got a phrase ID and a sentence ID. But the only thing that you really need is the phrase and the sentiment. We do not have any missing values in train, which is good because we don't have anything that we need to compute. We've got test, which is a phrase, and then an ID. And then we don't have any missing values in test, so we don't have anything to impute either. And then we have the submission. So the submission is going to be the sentiment and the ID, and that's what we're going to predict on in the test set. So we're going to analyze train, so label equals train sentiment, and then we're going to use seedborn to create a histogram of that, and the kernel density estimate is true. So you can see most of the scores were number 2, which is neutral, and so you had 0 and 4 were the least amount of occurrences, and 1 and 3 were the next to the least amount of occurrences, and 2 was the highest occurrence. But what you can do is what we did was a value counts. And when we did a value counts, you could see how many we got of each occurrence. So we wanted to see how many classes we had. And so num classes equals label.inUnique. And that tells you that there are 5 classes, 0, 1, 2, 3, 4. So now what we're going to do is we're going to prepare the data set. So X equals train phrase, and X test equals test phrase, and Y is your label. And then what we do is we use pandas to one-hot encode the label, because when you're dealing with TensorFlow, if your categorical label has more than 2 classes, then what you need to do is you need to one-hot encode it. So you can either use TensorFlow's I think it's 2 categorical, I'm not sure, or you can use pandas one-hot encode get dummies. You can use pandas get dummies, but I would rather use pandas get dummies. I think that it worked a little bit better for me to use pandas get dummies. So y one hot equals pd.get dummies y, and then you've got y one hot. So you can see we've got 0, 1, 2, 3, 4 columns for y, and each column relates to a different variable or a different number. So now what we do is we use sklearn's train test split to split the data set, the X and the Y1 hot, into training and validating sets. So that's what we've done. X train, X val, Y train, Y val equals train test split, X, Y1 hot, text size equals 1, random size equals 42, shuffle equals Y. And then you check the shape of all of those data sets or data frames to make sure that they're the shape that you want. And now what we're doing is we're going into TensorFlow. And when we get into TensorFlow, what we want to do is we want to import all of the libraries, TensorFlow libraries, that we're going to need to create our model. So then after we've done that, then what we want to do is we want to convert our pandas data sets to TensorFlow. So xtrain ds equals tf.convert to tensor xtrain. You do the same thing with xval, ytrain, yval, xtest. So now you've got xval ds, ytrain ds, yval ds, xtest ds. Now what we want to do is we want to vectorize our phrases, and we're going to create a function to vectorize our phrases. The function is custom standardization. It's going to take the input data as input. We're going to convert the data to lowercase, and then we're going to strip HTML from the data, and then we're going to return TF strings, regex, replace stripped HTML with different variables. over re.escape string punctuation. So now what we're going to do is we're going to check our max features is 10,000 and our sequence length is 250. So text vectorizer equals layers, text vectorization, standardize equals custom standardization, max tokens equals max features, output mode equals int, output sequence length equals sequence length. Features equals xtrainds text vectorizer.adapt feature. So you have to adapt them. And now we get the vocabulary. And this is where I tried to be able to remove all the words that were less than 3 characters because they have very little meaning. But I couldn't do it. I even asked the question on Stack Overflow, and I couldn't do it. So if any of my viewers know how to remove the words less than 3 characters from a tensor, I would love to know, because Stack Overflow hasn't told me either. Now what we do is we create a function called preprocess, and it returns text vectorizer. And now we're going to give an encoded example equals text vectorizer xtrainds the first 3 rows and convert it to NumPy. And so you can see the first 3 rows converted to NumPy. So now what we do is we print off for these first 3 rows, we print off what the text is when it hasn't been vectorized, and then we print off what the text is when it has been vectorized, and so you can see that. Now we define our model, which is a recurrent neural network, and we use Keras sequential model to do that. Text vectorizer is the first layer of the model, and then embedding is the second layer, and then bidirectional is the third layer, dropout is the 4th layer, dense is the 5th layer, dropout is the 6th layer, and dense is the final layer. And you'll notice that if you have more than 2 classes, then in the final layer it has to be the number of classes, which is 5. The activation is softmax, and the name is output. So now what you can do is you can see a summary of the model. You can see what it looks like. Now what we do is we're going to compile the model. The loss equals categorical cross entropy. Optimizer equals atom. Metrics equals accuracy. And then so we print off some pictures which didn't print off here. And now what we're going to do is we're going to train the model. I trained it only for 10 epochs because it takes such a long time to train it. But we set it up for early stopping and model checkpoint. So history equals model.fit, xtrained ds, ytrained ds, epochs equals epochs, which is 10, validation data equals xval ds, yval ds, and then you've got callbacks equals early stopping and MC, then you've got verbose. So it went through 10 epochs, and you had an accuracy of a validation accuracy of 6550. So now what we're going to do is we're going to evaluate the accuracy, and you can see we have an accuracy of 6550. We couldn't get the picture out, but that was just a diagram of the loss and the accuracy, but for some reason it didn't show it. I guess I didn't have enough memory to show it. And now we make predictions on your xval ds. So you've got your ypred classes equals np.argmax, ypred axis equals 1, ypred classes. So you can see it set it up for classes. And now what we did is we did a plot, a histogram of the Y-pred, and it would just show you something similar to the first histogram, which it didn't show it on this Jupyter notebook, but I put the code in there. And now what we're going to do is we're going to predict on the test set, which is exactly the same as predicting on the validation set. And then so we tested our prediction. We got our numbers on our prediction. And then we put it up on a disk plot, but it didn't show it on this disk plot. I think I didn't have enough memory, perhaps. And now what we do is we prepare our submission. So submission sentiment equals prediction classes, submission to CSV, submission.csv index equals false, submission equals read CSV, submission CSV, submission. So you can see this is our submission. And so I submitted it to Kaggle, but the competition has already ended. And because the competition has already ended, I scored 59%. There are things that I could do to improve my score, which would be to let it iterate through more, let it put more epochs. Let it train it for more epochs. That is one thing that you could do to improve your score, but because it took such a long time to train it, I only trained it for 10 epochs. Another thing that you can do is you can try to remove the words that are less than 3 characters. I wasn't able to figure out how to do that, but if any of my viewers want to know how to do that and want to let me know, I certainly would be grateful for that information. But I'm going to have to close this video because when I was making this video, I got a phone call and I've got to find out the contents of that phone call. So thank you so much for watching my video. Thank you to my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you again for watching my video. I look forward to making more videos for you in the future.